All right, today we're going to be talking about the Unbalanced Forces Lab, otherwise known as the Net Force Lab. Okay, so in the lab we had our force sensor slash accelerometer, and we had to push it back and forth with various masses. What you should have found from your data is that you should have created scatter plots and found out that as you added more mass, the slope of your graph would have increased. So it follows that the slope of the net force versus acceleration graph is equal to the mass. So quick note on direction is in algebra class, we know that there are 4 quadrants. And in quadrant 1, we have if x is positive, so is y. Quadrant 2 will have a negative x, but a positive y. Quadrant 3, both x and y's are negative. And in quadrant 4, we have a positive x, but a negative y. In this lab, you should have noticed that for the most part, our data would have been located in quadrant 1 and 2. And what that means is that for the net force, if you push it forward in the positive direction, you apply a positive net force, the acceleration is also in the positive direction. Likewise, if you pull it in the negative direction, apply a net force in the negative direction, it accelerates in the negative direction too. The short of it is the net force and the acceleration are always in the same direction. And this is something we've talked about in the previous unit, where if there are unbalanced forces, we know that an object's accelerating. But now we know that the net force is in the same direction as the acceleration. So here we have Newton's second law of motion, which states an object's net force and acceleration share the same direction and are directly proportional to or linear with one another. So the net force is equal to the mass times the acceleration. All we do is we get that from the y equals mx plus b. And it turns out that if there's no force, then if there's no net force, then there's no acceleration. So there really isn't a b there. Okay, and we have our net force equation, which is the net force is equal to ma. Okay, so before I let you go, you're probably wondering, what about the first law? It turns out that the first law was everything that we did in Unit 4. So from the hovercraft lab, we learned that an object is going to have the same velocity if the forces acting on it are balanced. And in wording that you may have heard before, Newton's first law says an object in a certain state of motion stays in that state of motion unless it experiences a net force. In our class, what we said it was an object will have a constant velocity unless the forces acting on it are unbalanced, aka it experiences a net force. So that was the whole thing about Unit 4. It's really Newton's first law of motion, also known as the law of inertia. And Newton's second law is pretty much just a continuation. It explains to us what happens when the forces acting on something are unbalanced, or if it experiences a net force. Okay, so we'll talk more about this later, and I'll see you in class.